Good morning. It is a beautiful sunny Thursday morning, a little bit cold. This is Henry from ASM Tutoring, once again attempting to serve as your wise old sensei. Today's lesson will build off of yesterday's lesson regarding center of mass. So let's head over to the handy dandy whiteboard here. So, a review of yesterday's formulas. If you had 2 points, M1 and M2, at locations x1 and x2, then the formula to find the center of mass would be you take the product of each individual mass and its x coordinate, add those up, and then divide that by the total of the masses. You can also write it in summation notation or with an integral, as shown in the middle line on the screen. So I've drawn here on the x-axis 3 separate masses. At position 1, there's a 15-gram mass. At the coordinate 3 on the x-axis, there's a 3-gram mass. And at coordinate 6 on the x-axis, there's a 7-gram mass. So let's try and find the center of mass of this system of points. Let's see here. Okay. So we take 15 times 1 plus 3, the 3 grams, times 3, the x-coordinate of the position on the x-axis, plus 7 grams at position 6 on the x-axis. Our denominator is the sum of all those masses, 15 plus 3 plus 7. Now, even before we run the numbers, we should expect the center of mass to pull somewhat towards the left of this spread of masses because the 15-gram mass on the left is much heavier than the other two masses. So, let's run the numbers. We have 15 plus 9 plus 42 all divided by 25. So that equals 15 plus 9 is 24, plus 42 is 66. 66 over 25. Now we'll pull up our calculator. 66 divided by 25 equals 2.64, which would fall right around here. That would be the center of mass. As expected, it pulls somewhat to the left because the 15-gram mass on the left end is much heavier than the other two masses. This has been a simple demonstration of how to calculate the center of mass of a system of points spread out along one dimension. If you'd like to learn more, I am available for hire as a private tutor. You can see my contact information in red at the top center of the screen, the whiteboard. The first 1-hour lesson is free for all new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding service in helping you succeed. And as a thank you for watching all the way to the end of today's lesson, please mention the code FREEBOOK when you contact me. And at our first lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. This book is available on the Barnes & Noble website. I wrote this book in an effort to provide guidance and wisdom to help students, and particularly high school and college students, to succeed in school, in work, and in life. Thanks for watching. Have a good day.